So now let us see what is path function and point function. We have seen what is heat and work, but what exactly do you mean by path function and point function? So let us take 2 points, A and B. So I can travel from A to B through this path, that is path 1, and I can also take this path A and B. You definitely know that this distance is shorter. Okay, path 2. So I can take another path, that is path 3. So if you calculate the distance in 1, 2 and 3, both will be different because the distance between A and B through path 2 is the lowest. Okay, and path 3 it will be the highest. So distance 1 is not equal to distance 2 is and not equal to distance 3. Okay, distance 3. But if you take the displacement in path 1 is equal to displacement in path 2 is equal to displacement in path 3. So this is the difference. You can say that this displacement is a point function and this is a path function because this distance depends upon path and displacement does not depend upon the path. It depends only upon the initial and final point. So this is the difference between path function and point function. So I have shown here a system initially at state 1. This is the PV diagram. The y-axis you have pressure and x-axis you have the volume. So see, initially it is state 1 and state 2. Now if it moves from 1 to 2 through path A and path B and path C. So system state changes from 1 to 2 through path A, B and C. So if you check the uh, change in pressure and change in volume between state 2 and state 1, see it depends only upon, see change in pressure depends only upon P2 minus P1 and volume I can say that it is V2 minus V1. That means the pressure and volume does not depend upon the path. It depends only on the end point, so they are called point functions. All properties, pressure, volume, temperature, etc., and all the properties are point functions. So what are path functions? Okay, so you can see that change in volume dv integral 1 to 2, it is v2 minus v1. Just you are taking the end points, volume at point 2 and volume at point 1, and then you have the, but if you calculate the work between 1 and 2, work done in 1 2 in the process 1 2, this is not equal to, you cannot write like this w2 minus w1 because all will be different. You know that this work can be easily calculated by the area under the graph. So if you note that all, you can see that through different process A, B and C, work will be different. So work actually is a path function. It depends upon the path. Similarly, heat is also a path function. Uh, these two are the path function. So you can write only like this: dw is equal to w12. And also note that this you cannot write dw. You need to use inexact differential. So this symbol is for inexact differential. You can write dv, dp, dt, etc. But you can only write like this: dw, dq, etc. This is equal to w12 and dq is equal to q12, etc. So these are the various ways. And note that q and w are path functions. And this d is called the inexact differential. This is called the inexact differential. So this is used only for path functions. We use this for path functions.